infinity 2x plus 1 over 4x squared plus x. Well, it's very clear that when you replace x by infinity, this will be of the form infinity plus infinity, because when x equal to infinity, 2x plus 1 is infinity. Alright, so this is of the form infinity divided by infinity. This is of the intermediate form, therefore we can use L'Hopital's rule there. And what's that rule? Limit, I'm going to repeat it every time. Limit x approaches c, f of x divided by g of x is the same as limit x approaches c, f prime x divided by g prime x. So this will be limit x approaches infinity, derivative of the numerator divided by derivative of the denominator, and that will be derivative of the numerator is 2, derivative of the denominator is 8x plus 1. There you go. Alright, now tell me, if you understand the concept, what happens if you replace your x by infinity? It will be 2 divided by 8 times infinity plus 1. Well, if you multiply infinity by any number, it will still be infinity. If you add any number to infinity, it will still be infinity. That means 8 infinity plus 1 is infinity. What is 2 divided by infinity? What do you get if you divide a number by infinity? These are important concepts that you cannot do without. When the denominator becomes infinity, the value of that number is 0. Any number divided by infinity is 0. So the value of this limit is 2 over infinity. That is 0. Okay, let me ask you, what is the value of, how about this? What is the value of limit x approaches infinity e to the power of negative x? What is the value of that? X approaches infinity e to the power of negative x. Well, it is x approaches infinity 1 over e to the power of x, and when x goes to infinity, it will be 1 over infinity, and that will be 0. And if you know the graph of this e to the power of negative x is an exponential decay graph, and as x goes to infinity, you see the graph will asymptotically approach the x-axis. That is the meaning. Limit x approaches infinity, e to the power of negative x is 0. Okay, let's do another one. Evaluate the limit square root of 4 minus x squared. Limit x approaches 2 from the left. Square root of 4 minus x squared over x minus 2. But why do we have this limit x approaches 2 from the left? Because for this x cannot approach 2 from the right. Why not? Because if x approaches 2 from the right, this value will be greater than 2 squared. That will be inside the square root, you get a negative sign. So this quantity is defined only if x approaches 2 from the left. In other words, x squared has to be less than 4. Okay, try this. Well, if you replace your x by 2, you get 4 minus 4, 0, 2 minus 2, 0. That will be 0 over 0. There you go. That is the intermediate form. That means this limit can be evaluated only by using L'Hopital's rule. So that will be limit x approaches 2 from the left, square root 4 minus x squared over x minus 2 is the same as limit x approaches 2 from the left, the derivative of the numerator divided by the derivative of the denominator. Alright, let me see how many of you remember what is the derivative of square root of 4 minus x squared. it is easy to remember like this. The derivative of a square root quantity, this is the quantity, is 1 over 2 square root of that quantity multiplied by the derivative of that quantity. So the derivative of this will be, now look at the way I'm going to write with my marker, my pointer here. The derivative of this quantity will be 1 over 2 square root of that quantity, 4 minus x squared, times derivative of this quantity is negative 2x. So the derivative of this will be actually negative 2x divided by 2 times square root 4 minus x squared, and the 2 and 2 will cancel. You see, this will be 1 over 2 square root 4 minus x squared times the derivative of 4 minus x squared is negative 2x. Alright, that's the derivative of this. And what is the derivative of x minus 2? That is 1. Alright, can you now replace x by negative 2 and see what happens? Simplify this, you get limit x approaches 2 from the left, negative x over square root 4 minus x squared. And if you replace x by 2 here, the denominator becomes 0. The numerator, it will be negative 2. Is that right? So replace x by negative 2. That will be, well, this is not quite right. Yes, it is right. X approaches 2 from the left. Replace both your x by 2. That will be negative 2 divided by square root 4 minus 2 squared. That will be negative 2 over 0. What is a number divided by 0? A number divided by 0 is infinite. So this will be negative infinity. The limit x approaches 2 from the left of this quantity is negative infinity. Now, can you try that on your calculator? Now look at this. This is the graph of this function as x approaches 2 from the left. This is x equal to 1, x equal to 2. As x approaches 2 from the left, what happens to the function? It goes to negative infinity. Now, you see why x cannot approach 2 from the right. Because the function is not defined for x greater than 2. Okay. Another one. Evaluate the limit. Limit x approaches 1, ln x over x squared minus 1. Can you test if L'Hopital's rule can be applied here? What's the condition for L'Hopital's rule to be applied? When a direct substitution of the limit should give you an intermediate form, 0 over 0 or infinity over infinity. Alright, replace x by 1 here and see what form is this. What is ln of 1? ln of 1 is 0. And when replace x by 1, this is 1 minus 1, 0. That is 0 over 0. So that is intermediate form. And therefore, we can use L'Hopital's rule. Limit x approaches 1, ln x over x squared minus 1 is the same as limit x approaches 1, the derivative of the numerator divided by the derivative of the denominator. That's right. And what is the derivative of ln x? Derivative of ln x is 1 over x. And the derivative of x squared minus 1 is 2x. So that will be limit x approaches 1 of 1 over x divided by 2x. What is that equal to? 1 over x divided by 2x is 1 over 2x squared. And what is the value of this when x equal to 1? That will be 1 over 2 is the value of that limit. Alright, try that graphically and see if you can get it. Alright, what's this graph? This is the graph of ln x divided by x squared minus 1. Now watch what happens when x approaches 1 from the left and x approaches 1 from the right. You notice here that this function is not defined for x equal to 1. You can see there's a hole there. That indicates that the function is undefined at x equal to 1. But as x approaches 1 from the left and x approaches 1 from the right, the function value approaches 1/2. Now this is 1/2 because I have used the scale so that that's 1, this is 1/2. Okay. Another one. Evaluate the limit x approaches 0, sine ax divided by sine bx. Sine ax divided by sine bx. Can you replace x by 0 and tell me what form this is? When x equal to 0, you get sine of 0. What is sine of 0? Sine of 0 is 0. So you get 0 over 0. And that is intermediate form. Therefore, we can use L'Hopital's rule. Limit x approaches 0, sine ax over sine bx is the same as limit x approaches 0, derivative of sine ax with respect to x divided by derivative of sine bx with respect to x. There you go. What is d by dx of sine ax? The derivative of sine ax is cos ax times the derivative of ax, which is a. So the derivative of sine ax is a cos ax. And the derivative of sine bx is b cos bx. So this will be limit x approaches 0, a cos ax divided by b cos bx. And now if you replace x by 0, what happens? Do that. When x equal to 0, ax is 0, what is cosine of 0? Cos 0 is 1. So on the numerator and the denominator, cos 0 becomes 1, and therefore the value of that limit is a over b. That's right. So limit x approaches 0, sine ax over sine bx is a over b. Limit x approaches 0, sine 2x divided by sine 3x will be 2 over 3, and so on.